Bismillahirrahmanirrahim. Assalamu alaikum. Our today's topic is about ionization of water. Now let's dive in a topic. In this video, we learn about the autoionization of water, understand what the autoionization constant of water is, and explore the Kw constant to determine concentrations of ions. It is the dissociation constant and ionization of water. One molecule of water acts as an acid. It donates its proton. And the other molecule of water acts as a base. It accepts the proton of another molecule. After releasing this proton, the water molecule becomes OH negative ion, and after receiving the proton of other molecule, this water molecules become H3O positive, that is hydronium ion. This is the autoionization of water. One molecule of water acts as an acid and the other molecule of water acts as a base. Now the acid-base properties of water. As water is amphoteric, water can act as both an acid and a base in solution. When mixed with a base, water donates hydrogen ions and acts as an acid. However, when water is mixed with an acid, it accepts hydrogen ions and acts as a base. Water molecule acting as an acid. When water molecule reacts with a base, it is ammonia. It donates its proton and this water molecule acts as an acid. NH3 accepts the proton of water molecule and become NH4 positive, that is ammonium ion, with the release of OH negative ion from water molecule. Water acting as a base. When an acid dissolves in water, water acts as a base. It accepts the proton of an acid and form hydronium ion, that is H3O positive. In this reaction, water acts as a base because it accepts the proton of an acid. After the releasing of proton, acetic acid converts into acetate ion and water molecule converts into hydronium ion, that is H3O positive. Because water molecule accept the proton of an acid, so in this reaction it acts as a base. During autoionization, water can be both an acid and a base to itself. It is a water molecules. One molecule of water acting as a base because it accepts the proton of another molecule. So this molecule of water, by accepting the proton of another water molecule, form H3O positive ion, and the other molecule of water which donates its proton, it becomes OH negative ion. During autoionization, water can be both an acid and a base to itself. This water molecule acts as a base because it accepts the proton and form H3O positive, and the second molecule of H2O acts as an acid because it releases its proton. It is the autoionization of water molecule. It is the molecular structure of water. This water molecule acts as an acid and donates its proton, and the second water molecule acts as a base. It accepts the proton of another molecule of water which acts as an acid. A molecule of water which acts as a base form hydronium ion, and the second molecule of water, it acts as a base as an acid. This water molecule acts as an acid. This form hydroxide ion. It is a reversible reaction. In backward reaction, this hydronium ion is acidic in nature because it is able to donate its proton, and this hydroxide ion acts as a basic in nature because it has a tendency to accept the proton of hydronium ion. This is the autoionization of water molecule. Now the ionization equilibrium. The bonds between water molecules rapidly break and reform. Sometimes the bonds break in an uneven way to give solvated H3O positive and solvated OH negative. During solvation, H3O positive is surrounded by water molecule and OH negative ion is also surrounded by water molecule. We typically abbreviated the cation part as H positive and the anion part as OH negative, with the realization that the solvated proton and solvated hydroxide anion are complexes and stabilized by many water molecules. Relative to water molecules, the concentration of H positive and of OH negative are very low, but because they are in equilibrium with liquid water, the concentration are constant. The water molecule, the H positive and OH negative. The K equilibrium is the ratio of molar concentration of product and the molar concentration of reactant. The product is H positive and OH negative, and the reactant is H2O. This H2O goes here, and the equation becomes K equilibrium H2O, which is equal to Kw. And Kw, it means K equilibrium H2O. We also stands it's for Kw, and Kw is equal to H positive, that is molar concentration of H positive, and molar concentration of OH negative. Kw is the product of molar concentration of H positive and molar concentration of OH negative. The molar concentration of H positive is 1 into 10 raised to the power minus 7 and the molar concentration of OH negative is 10 raised to the power minus 7. So its product become 1 into 10 raised to the power minus 14 mole per dm cube square. pH and acids. Because of the self-ionization, water is a Bronsted acid. That is, it produces H positive ions in solution. We can calculate the molar concentration of solvated protons from the expression for Kw. In neutral water, the concentration of H positive and of OH negative must be equal. Concentration equilibrium, it is H2O after autoionization becomes H positive and OH negative. So its concentration is denoted by X, which is the concentration of H positive is exactly equal to the concentration of OH negative. So Kw, that is 10 raised to the power minus 14, is equal to X square. Taking square root on both sides, we get the value of X, that is 10 raised to the power minus 7. So the concentration of H positive is equal to 10 raised to the power minus 7 m or 10 raised to the power minus 7 mole per dm cube. We can define a quantity related to acid concentration, pH. The pH is minus 1 time the log of the hydrogen ion concentration. The pH of neutral water is 7. H2O forming equilibrium H positive and OH negative. The concentration of H positive is equal to minus 7 m. Mathematically, pH is equal to minus log the concentration of H positive, that is minus 7, which is equal to 7. We can determine the pH of any solution by converting the concentration to a power of 10. The pH is then minus 1 time the exponent. Remember that we have used an abbreviation log table to convert whole numbers to powers of 10. POH and bases. Water is also a Bronsted base because it produces OH negative ions in aqueous solution. OH negative ions in solution. We define POH as minus 1 times the log of the hydroxide ion concentration. The pH and the POH of any aqueous solution are related through the Kw. The molar concentration of hydroxide ion is equal to 10 raised to the power minus 7 m or 10 raised to the power minus 7 mole per dm cube. POH is equal to minus log OH negative ion, which is equal to 10 raised to the power minus 7. After calculation, we get the value of 7. So, Kw is equal to the molar concentration of H positive and the molar concentration of OH negative. Kw is the product of the molar concentration of H positive and the molar concentration of OH negative. Minus log Kw is equal to, taking minus log on both sides, so minus log Kw is equal to minus log and the molar concentration of H positive multiply the molar concentration of OH negative. Minus log multiply by 10 raised to the power minus 14 because the value of Kw is 10 raised to the power minus 14. So the substitute the value of Kw in this position is equal to minus log H positive plus minus log OH negative because both the substance are multiplied by each other. So we convert the equation by putting plus sign here. Minus log 10 raised to the power minus 14 is equal to 14. Minus log H positive is equal to pH plus and minus log OH negative is equal to POH. So we substitute the value of minus log H positive and the minus log OH negative in this equation. So pH plus POH is equal to 14. Thank you very much. Allah Hafiz.